Okay, so we're doing question 4 from exercise 10F from the first year mechanics textbook. So we've got two particles, light inextensible string, and we're on a horizontal table with a string passes over a smooth pulley, and we're given some information about friction. So let's just get a sketch of that so we're clear what's going on. So I've got a table, I've got a pulley, okay, and then I've got, particle A is the one that's on the table, so there's going to be tension in the string that's pulling particle A along. Mass of particle A is 5 kilograms, so its weight is 5g. There is a reaction force. It's not actually going to be relevant for this question, but let's label it up. And I'm also told there's a friction force of 24.5 newtons. So then I've got this smooth pulley, so tension is going to be the same along the string. So then I've got particle B, and I'm told the mass of particle B is 3g. Okay, and the system is released from rest. So I think that's all that information. So we want the acceleration of the system. Okay, so I can look at particle A or particle B, and I'm probably going to need to do a force diagram for each of them. So for particle A, I'm only interested in its its horizontal forces. So it's being pulled along by the tension. It's got a friction force of 24.5 newtons. It's obviously going to be moving in that direction, and it's got a mass of 5 kilograms. So using F equals ma, and we'll take right as positive. The resultant force is the tension minus 24.5. The mass is 5 kilograms, and I'm trying to find acceleration. So I've got two unknowns there. I don't know tension and I don't know acceleration. So I need a second equation. So if I think about what's happening with particle B, okay, and particle B is moving downwards, and it's going to be moving downwards with the same acceleration as particle A is moving to the right, because the string is inextensible, and the tension is going to be the same. This tension and this tension will be the same, because the string is light and the pulley has no friction. So if I use F equals ma for, so I should have labelled that one as particle A, and this is particle B. So if I use F equals ma, and it's moving down, so I'm going to take down as positive. So 3g minus t is the mass times the acceleration. Okay, so I've got two equations, and if I just add them together, I'm going to eliminate t. So if I do equation 1 plus equation 2, so I've got, so the t minus the t are going to cancel. So I've got 3g minus 24.5, and I'm adding them. So I've got 5a plus 3a, so that all equals 8a. So that goes straight into my calculator. So 3 times 9.8 minus 24.5 is 4.9, and that equals 8a. So if I divide that by 8, and I get an acceleration of 0.613 meters per second squared. That's rounded to 3 significant figures. Okay, right, and then I want the tension in the string. So that's quite straightforward. I can go to either of these equations. Okay, so now I know A. I can substitute it into either of those. So I'm going to take equation 1. So t minus 24.5 is 5a, and a is 0.613, or you could use 6125. That was the unrounded answer. So 5 times 0.6125 gives me 3.0625, and if I add 24.5 to that, I get a tension of 27.56, so 27.6 newtons. Let's just quickly check that. Okay, yeah, so far so good. Right, and then the magnitude of the force exerted on the pulley by the string. So there's two forces acting on the pulley, and they're actually just the same force twice. So you've just got the tension in the string. So I basically just want the resultant of those two forces. So I've got 20, so tension was 27.6. So there's 27.6 to the right and 27.6 down. Let's write over the side. Okay, so the resultant is going to be that force there. They're at right angles, so I can just use Pythagoras. So it'll be the square root of 27.6 squared and another 27.6 squared. So 27.6 squared, divided by 2, square rooted, gives me 39.0 newtons. Job done.